Well, today we are gonna pretty much pick up where we left off last time. If you remember last time, we we did a basic introduction to Python, starting with the string object. The string object, you'll recall, is where you can put text, any kind of text. It could be English text, it could be Turkish text, it could be Japanese text. Python is happy with that. And we learned a few different constructors. That's the fancy term for ways to make strings. And we'll go over a little bit of that. Let me share a screen. And I'm going to be doing everything in a Python notebook today, or a Jupyter notebook, as it's more appropriately called. And I'm hoping that you guys have it. Whether you have it or not, I'll be able to share this notebook at the end of class, and you'll be able to play with it. So you recall, I'm going to make this cell a markdown cell, like so. And so you'll recall we can make a string by just putting quotes around something, like so. And the Python interpreter will take this as a line of code, and it will interpret it, and it will echo back, because we're using the REPL, it'll echo back what it thought I said. All right, so far so good. If we want to assign a name to it, we could do that on the same line of code. So we can say a name, and we might want to make it a sensible name, and we can use the assignment operator in Python as it's an equal sign, like so. And now we've created within Python's namespace a name, which is this, and an object, which is this. Now, if we ask it to report out on the object, we can just give it the object name. Now, this is one cool thing about Python, and I'd like to point it out. One way to declare a string is to just put something in between quotes. That's going to be interpreted as a string. When Python tells us back what we did, look how it presents itself. The same thing. It puts quotes around it. And pretty much all the objects that we'll run into in Python, collections like lists and tuples and dictionaries, they all have their own way to tell Python what kind of an object it is. It might be braces or parentheses or quotes. And Python will always echo back, if it can, something really close to how you defined it. Right? There's a few ways to make strings. We can say a string can be double quoted, like so. We've already seen a string can be single quoted, like so. We can also use triple quotes, like so. And we can use triple single quotes, like so. They're all equally valid ways to make a string. With these two, C and D, the string can extend to multiple lines. So it'll be very happy with that if we wanted to put in a second line. So, if I could type, we'd be so much better off. There we go. S-E-C-O-N-D is how you spell that. So I'm gonna hit return. I'm gonna run this cell, and that's gonna put all these names A, B, C, and D into the Python namespace. So we'll be able to refer to all the strings that we define like this simply by their name. So we can ask it for A, and we can ask it for B, and C, and D. One other thing we pointed out last time, I'll point out again, is when we're just talking to the interpreter, like we say A, well, the interpreter will execute that line and report something out. And it'll do that via its REPL, right, which is the read, execute, print loop, right? Now, under the hood in Python, and you'll get there eventually, it's kind of beyond the scope of this class, but I'll just show you really quick. If we ask for the directory of a string object, this shows us the namespace of a string object. Every string is a particular kind of a string. This string A is a particular kind of string, and it has the value double quote. Okay. But because it's a string, it also has a lot of other things that it knows about. It knows how to add, for instance. That's what some of these funny things look like. It has documentation. You saw last time if we said help on a string, we'll just do that here. It'll tell us a lot about that string. Well, it can do that because it has a name inside of it called doc. And that's what gets executed when you say help. Add gets executed if you say plus. So we'll put in another cell above here, and we can ask it for A, and then we can ask it for A plus A. Because it has that A method, it knows what to do with it, and you can see the plus operator, which invokes this add method, simply pushes the two copies of the string together. Okay. And the reason I got on this topic here, I want you to know that all Python objects already know how to do a lot of things. They already have a lot of methods built into them. Like this knows what to do with a star sign. It runs the multiple or multiply operator. So if we said A times 5, it'll just replicate itself 5 times. We didn't have to tell it anything, but it could just dig into its bag of tricks. It's like a trained dog, and it knows all kinds of commands, and it knows all kinds of properties. Okay, one of these properties is called repr. It's actually a method, and that's here. And that's what the REPL uses. Okay. And this is a different method, and it might or might not produce the same kind of results as if you printed it. Okay. So if we wanted to look at D here, the REPL, the read execute print loop, printed it out like this. But if we use the method print, which we talked about last time, and ask it to print D, well, the print is a method, right? It's a program, and it takes an argument, and that's a string, or it can take lots of stuff, and it will render this with the line break as we input it, like so. Okay, so even a very humble object like a string in Python is already very powerful, and you don't have to do a hell of a lot to make it work for you. Okay, we saw last time that we have a bunch of methods, like we can ask it if it's alphanumeric. Okay, and we can do things like split it and make it uppercase. So we'll add a cell here, and let's ask it for A again. And if we use one of the methods here, we can say a dot upper, and that will make an uppercase version of a for us. And there's a method called lower, and there's a method called capitalize, and another called title. And it's all different ways to convert even a humble string to something a little bit more fancy. And you can on your own just use help or directory against a string. And you can go through, and I would encourage you to experiment, because that's by far the best way to learn about these objects, is to experiment in your own notebook and just see for yourself what they do. One thing that you're not going to find easily in help is a fact about strings that's very important to know. Okay, you'll notice that we just did this a dot upper command, and we got an uppercase string. What do you think we're going to get if we just ask for a again? Well, if you said, well, just get our original back, you'd be right. Because this operation, upper, doesn't change our original object. Okay, one of the properties of strings is that they are immutable. Okay, and that's just a fancy way to say you can't change them. Okay, so once you make a string, you can never, ever, ever change that string. You can reassign the same name to a different string, but you can't ever change that string. So if you wanted to do something like, say, we'll recycle the name A and we'll assign it to a new object. So we could assign this new object A to a dot upper if we wanted to, and get a different object out of it. That object we get out of it will be this. So that's a way to get the same name to remember some kind of transformation that you made to the original immutable string. Okay. So the takeaways are strings. Let's just add a couple of things to this. They're immutable. Okay. They have methods like upper and lower. Okay. And you can learn about them with directory and help. Okay. So we'll be seeing plenty more examples of how we can play with strings. But for today, we're going to move on to some new stuff. All right. And we're going to be moving into more data types. Now, Python supports many different kinds of data, right? A string can have text data, okay, but there's many more, okay? We can have numeric types, like integers and floating point numbers, and there's libraries that I'll just reference, where if you're not happy with the kind of numbers that Python has right out of the box, you can go into the Python libraries and get different kinds of numbers that do fancier things. So Python, just in its basic repertoire of behavior, will give you an integer and a floating point and a complex number. Floating points have problems; they're not very accurate. I can show you a way to get really accurate numbers. And I can reference you to libraries that vectorize numbers. and they basically can do really fancy, really fast things, working with object types that aren't known to just straight Python. But the cool thing is, everything you learn about numbers and other objects will be transferable no matter how fancy you get. All right. And we'll talk a little bit about type conversion. And that's how you take a variable of a type like Boolean and change it into a numeric type, or take a number and change it into a string, okay, or vice versa. Python has some really easy ways to flip your number or your object types from one thing to another. Okay. So we'll talk about variables for now. Okay. And we'll just talk about them in general. I'm going to move this off to the side so I can show you some code here. And let's get rid of some of this stuff. Remember, you can do a directory on any object, and you can ask for help on any object. And I absolutely encourage you to do those. So we're going to create a markdown cell, and we're going to put in here, well, hang on, let's do a markdown cell. Good. And we're going to put in here variables, general. Okay. So you might wonder, what is a variable? You hear that word thrown around a whole lot. And if you haven't done a lot of computer programming, maybe you don't know. A variable is just something with a name associated with it. It's an object. Object has a technical meaning, but all it is a thing known to Python. It's an object, and if you assign a name to that object, another way to refer to that name is it's a variable. Okay. Because you can address a variable. So let's just say we'll call it var, and you can assign it to something like a number, something like that. Well, if we ask the interpreter for var, if we ask it for var, it'll just go ahead and tell us what that variable means. Now, if we want to assign something else to this name var, we can just go ahead and do that. In fact, we can say var is equal to Pat. And then we can ask it to display itself, and we see that it's now Pat. So in other words, this name can take on any number of different values. So we say it's changeable or variable. That's how it got its name. All right. Now, you notice something here. I pointed this out last time, but it's worth noting because Python is really forgiving, especially for first-time users. We did not tell Python that our variable is an integer. And we didn't tell Python that our variable is a string. We just went ahead and made this assignment. Okay, so we were able to create a name and provided a value. And under the hood, by itself, Python made an assignment of a variable type to the name we provided based on the value that we gave it. All right, and if you ever wonder what type it gave it, you can just say type, and then you can give it the name of the variable, and it'll tell you what kind of variable Python thinks it is. Okay, so I need to execute this cell again because I overwrote the name var. So we'll execute that. Now variable is going to be equal to 1, 2, 3. And when we do that, we'll see the type of the variable is now an integer. If we recycle the name and provide some other different kind of value to it, Python will go ahead and acknowledge that fact. And if we ask it again for the type of the variable, it'll tell us it's a string. So it's said that Python is not strongly typed, right? And type is the kind of variable it is, which isn't exactly true. Python is strongly typed. It's just you don't have to intervene to tell it what kind of objects that it's going to have. And the technical term for that is Python will infer. So this is inference. Let's put a little variable type is inferred. Okay, and the other thing to know is the variable type, the variable name can be recycled. Okay, and it will, the type will be inferred again. Okay. Questions on that so far? Okay. We'll get into this later, but you might or might not be happy with the kind of variable that Python assigns to something. So for instance, you might get this variable somewhere in the world and you don't really want an integer. Okay. Maybe you want it to be a string. Well, it's pretty easy. And let's make this markdown. It's easy to switch. Variable types. Okay. And an easy way to do that is if we wanted to say our variable is a string, let's call it 789. We can ask for the type of this variable, and it'll tell us it's a string. Well, if we want to make it an integer, we could use the name of the thing we want to convert it into, integer, and we could give it our string as an input. That's how you provide information to a method or a function that Python knows about. You put it in parentheses. And if you do that, you can ask it to print the variable, and you can ask it to print the type of that variable. And you can put lots of things inside the parentheses following the word print because you're feeding different arguments to the print function. And this is going to tell us 789, okay? And this doesn't show up with quotes, does it? And it'll show us the type of the variable has not changed. It's still a string. We can upgrade this a little bit, and we can say variable equals an integer version of the variable like this. And we'll just copy this down here because we've already seen it. So we're going to ask it to print the name of the variable, or sorry, the value of the variable and what kind it is. Now the string is immutable. We can't change it. So by converting it to an integer, we really didn't convert it, but we did create another object, which is an integer. But the class of our original variable stayed the same because we can't change it. If we want to reassign it, we can do that. And we'll find when we print this that we have an integer. Okay, so what we did there. Okay. We can also do a multiple assignment statement in Python. It's not particularly recommended, but we can use an equal sign a bunch of times. So we can say something like X is the same as Y is the same as Z. And then we can make it the name of my dog, like so. And what it's going to do is it's going to interpret this Quinn the Husky as a string object. It's going to assign that string object to the name Z. And it's going to assign it to the name Y. And it's going to assign it to the name X. So essentially here, we have created an object, a string object, and we can see that they all have the same value. Now, here's another interesting thing about Python, and this is a little bit arcane maybe, but if you ever wonder whether two objects are the same, like X and Y, are they the same object? One thing you can do is put double equal signs in between them. Okay, and this asks the question that's going to have a true or false answer. Are these two the same object? And yes, they are. All right. And we would find the same thing with X equals Z. We have the same object. And if you ever really wonder whether they're the same object, you can use ID. Okay, an ID is going to tell us what the memory location occupied by this object is. Okay, everybody memorize that number? Nah, you don't want to memorize it. You can't do anything with this information, except this is how Python finds it. Any computer program is going to look for a location, and that could be in memory or it could be on a storage medium of some kind to find it. So it's like the address on your house or your telephone number. Well, you can ask if the object we called X is in the same memory location that the object Y is. And it's going to give us a true or false answer. And look, it's true. So what happened is Python looked at this object called Quinn the Husky, said, okay, it's a string, and I'm going to give it a name. I'll give it Z. But it didn't create a brand new copy of Quinn the Husky when we also assigned it Y. It used the same one. Okay, so we got one copy of it, and let's just ask again where it lives. So so Quinn the Husky lives at 1961, whatever. All right, so Python already knows that. So when we go do assignments, all it really does is it adds names to the same object. Okay. And the point of this is that you can have lots of names for one object, right? You can it can be a many-to-one relationship. All right, so Python is pretty efficient. Now, you got to be a little bit careful if you're working with objects that are changeable or mutable. So that's the opposite of immutable. All right. So if you have an object that can't change, you can do a chain of assignments like this, or you can do them independently, and you can add several names to the same object. But if you're going to do that, make sure that the object can't change, because if Python knows it can change, it won't necessarily assign it to a single address. It might figure that it has to go out and make new copies. Okay, any questions on how that works? Okay. So Python has a special object type called none. All right. Now, X is an object, we know that, right? Y is an object, we know that. The object has a name. Okay, we can ask the type. Okay, but there's a special type called none. So we can say, we can assign X to the special object type called none. That's spelled with a capital N. Okay, and that assignment will just happen. Now, if we want to report out X using the REPL, and you remember the hash sign is just a comment, everything past it will be ignored. We don't print anything, okay? Because that's the same thing as saying print none, and there's just nothing to print, okay? Well, actually, let's print X instead. That'll show you better. So with the REPL, there's no output. When we print it, right, the REPL and the print use different methods of underneath the hood, drawing from the object itself. We get slightly different output. Okay, so this exists. It's a real name. We can access that name. The value it has isn't a number or a string. It's just this object, and this object really doesn't do anything except for take up space. And it's an object known to Python, so you can do some things with it. And you can ask about it. If you want to know if X is none, is works kind of like equal, the double equal sign. So you can say X equals none, like that. Okay, and that'll give you true. And you can also say X is none, and that'll give you true. All right. So this asks if X is literally the none type. Okay, so basically, is the address the same? And this asks you a more general question. Is it a general kind of a object known as none? In this case, it gives us exactly the same number. So if you want to have a name that you can use, so let's just say you wanted to print cat, dog. And you know you want to do that, but you haven't defined cat or dog yet. But you don't want it to crash. If we just execute this, the interpreter is going to yell at us. And it's going to say, yo, dude, I don't know what you're talking about. I'm going to say name error. Okay. And the name error means just, I don't know. You give me a name. I haven't associated it with an object. So I just don't know about it. You go cat yourself. However, if you wanted to, you're writing some code and you wanted this statement to execute, but you don't know what cat or dog are yet, you can say cat equals none. And you can say dog equals none. Now you can say print cat and dog. And the interpreter will be completely happy with that. Okay. So none is a really good object to know about. You'll see it used as a placeholder quite a bit. And what it's doing as a placeholder is it's tying together a name and an object already. So the interpreter isn't going to get confused if you try to use that name. Okay, so far so good.
Pat,
Yes.
to be honest, I didn't get why we are using none. What is the main purpose to use the none?
Okay. Thank you for the question. The main purpose to use none is just to establish a name that Python knows about. Okay. Python won't remember a name unless it also remembers an object of some kind. So if you want to give it a name and have it remember that name, like X, and you don't want to assign it anything meaningful, you can just assign it the none object, and that will make Python remember the fact that this is a valid name. Does that make sense?
Yes. So why we are looking for something it's gonna be meaningless for the Python? So its X is gonna be none. So the Python is not gonna remember if we are gonna put, I mean, if we are gonna give to X anything.
Well, okay, that's a good question too. Well, let's just say we're developing code, okay, and we're just starting to write our code, and we know we're going to have to do something with cats and dogs, and we might ask the user a question, and we might say answer equals input, do you have a dog? Okay, and this is a way for Python to solicit information from a user. Okay, so what it did is it echoed back this string I gave it here. Do we have a dog? And then I might say, yes, I have a dog. All right. Python now knows the answer. Okay. So I might say, if the length of the answer is bigger than 0, I might then say dog equals answer. If I want to say the length of the answer is equal to 0, and length is a built-in Python function that tells you how long an object is. So if we wanted just to ask it the length of answer, it'll tell us 3 because our answer is YES. So if we want to ask if the answer is bigger than 0, in other words, did we answer that question? We might assign the name dog to answer. Now, if we ask it to report on what dog is, we see dog took the same value. Okay, so we might want to do something like this with our code. And as we're developing it, we'll want to be able to use this print statement. Okay. So here we've said that, okay, we don't have a value for cat, but we can print out a placeholder value of none. We've got the bit of code that assigns a value to dog, and we can report that. But this statement will work wherever we are in our code development process. Another use case, and I don't want to get too far ahead of ourselves, but if you want to make a little self-contained code block, it's called a function. You can use a Python keyword def, and you can give it a name. And one way you can assign stuff to it is you can say dog is none and cat is none. Okay, and then you can print dog and cat. Okay, that's how to encapsulate a little bit of code. That way you don't have to write the same code more than once. Well, you can execute this function by saying dog equals Quinn. Like that. Okay, so you provided a single argument to it, and it'll report the dog and the cat. And you can also, if you want to, you can give the cat a name, like Barfy. Okay, and you can say cat equals some name, and it'll print these things out. Or if you wanted to just execute the function with the execution operator, not providing any names, it'll give you none back. So in this case, in both the cases that I've showed you, the none object is a placeholder that makes valid code. And it's usually provided in anticipation of the possibility more information will be provided later. It might be through calling a function, it might be through providing input, it might be by scraping something from the internet. But the Python code is valid no matter what. Does that make sense?
Yes, now it's more clear.
Okay, good. Okay, we got time for another question before we take a break. Who wants to be the lucky one to ask me a question that I don't know the answer to? Oh, come on. Anything but the meaning of life. Or how to get
I have a really hard question.
Sure.
Why I didn't understand the difference. We use equal sign, one or double. I know it's so hard.
That's okay. So let's see. Let's answer your question quickly now, and I'll answer it a little bit better when we get back.
Mm-hmm.
Let's just make markdown, and we'll say that or that. Okay. Actually, I already screwed that up, didn't I? So we want one equal sign or two equal signs. Okay, so an equal sign is an assignment. Assigns a name to a value. Okay, so you can say A equals 999, and you get A. Okay, now if you say double equals, you're asking a question. Are two things the same value? Okay, so if you say A equals 999, you'll get a true or false answer out of it. Does that make
Got
sense?
it. Yes, perfect. Thank you so much.
Awesome. Okay, it's break time. So I'll see you in about 15 minutes at the top of the hour. Okay. Enjoy. Hello, guys. Welcome back. I hope you had a good break. And let's jump into a little more Python. Okay. Was the answer to my last question, or the last question, does it still make sense, the difference between a single equal sign and two equal signs? Okay. Does anybody have questions about what we've talked about so far in terms of creating names and assigning them to values, or of strings being immutable, the use of the word none? Okay. Okay. Well, so far I've shown you how you can assign a variable to a value. You can also assign, you can assign variables to other variables. Okay. So if we wanted to make the statement that we haven't picked on zebras, we can say a zebra is going to be equal to 2, 3, 4. We know how to do that because we've got a name. Whoop. We have a name and an assignment operator and a value. And that is sufficient to make the Python interpreter know what the name zebra is and what it's associated with. So it's associated with the integer 2, 3, 4. But you can also say yak is equal to zebra. Okay, so we've got a new name and we're going to assign it to a variable, and Python will know what yak is. Okay, so we kind of did this as a chain where we assigned x and y and z to the same variable in a format like this. Okay, but we can also just have a variable assigned to another variable and it'll work just fine. Okay. Another thing, another way to assign variables is something like this. We can assign via an unpacking operation. Okay, what is that? Okay, so if we have a collection of objects, so we're going to take a collection and we're going to turn it into individual name object pairs. Okay, so the first question is, what is a collection? Okay, a collection is the same as a bunch of objects. Okay, and there's a few kinds of collections in Python. I'll just mention them quickly here. We can have a tuple, we'll call it tuple A, and that is just a combination of things we'll give this tuple an integer and a floating point and a string, like so. And we'll ask it its type. Okay, we see we made a tuple. Now, the way you make a tuple is you use parentheses, like so, and you combine objects by putting commas in there. If we ask it to report on itself, you'll see that what it spits out looks like what we gave it, right? We've got a collection of things, 3 things separated by commas, surrounded by parentheses. You can also have a list. And you can make a list with square braces. And you can put any number of things in it. Like so, they don't all have to be the same things, which is kind of cool. Python object collections don't require that. Some languages do. So if we wanted to print here, type, and we can ask it the type of list A, it'll give it to us. And then if we asked it just to report what list A is, we can do that through the REPL like this. And again, the list object will, one way to create it is to put a bunch of things between square braces, and it'll report itself as being a bunch of things between square braces. Okay, so lists and tuples are 2 examples of Python collections. Okay, most collections are iterable. That means they know how to loop. Through the elements. Okay, so you can easily ask a tuple to tell it each of its elements in turn. So you could easily say for element in tuple A, print element, and it'll know how to loop through. You can say for element in list A, you can print element. It'll know how to do that. Okay, so I'm just going to put a comment in here. Collections are usually iterable. Another thing you can do with a collection is you can unpack it. Okay, and what that means is you provide names, one for each element. All right, so we have an object called tuple A, and this is really weird syntax, but you can say R, S, and T equals our tuple. When we execute that, it's going to already know, or after we execute it, it's already going to have RR, SS, and TT into the namespace. The namespace is just the names that Python knows about. Okay, so you can unpack with this kind of an operation. You need the same number of elements over here as you do objects inside the tuple. That's the only rule. So that's an alternative way to assign names. And you can use this unpacking operation it works on any iterable, loopable collection. All right, so we can say AA, BB, CC equals list A. And it'll give us AA, BB, and CC back out. It will if I type it right anyway. Okay. Now, here's something that might come as a surprise to you. Strings are collections of really short strings, characters. All right. So if we can have my string and make it equal to XYZ, like so, we can now say my X, my Y, and my Z equal my string. And if we wanted to print those out, we could do it with a print statement. Like so. All right. So the string is an iterable collection. We're able to loop over it. All right. We could say for character in my string, we could print the character. Just that easy. Okay, I didn't want to belabor too much, but the point here is that we've got different ways of assigning things. Okay, we can assign things directly with an equal sign, like this. We can assign things by chaining together equal signs, right? So in the case it's highlighted here, we've assigned 3 separate names for the same object called hey. In this instance, we made an assignment using the equal sign, and we've assigned the value of a variable to another name. Here we made a direct assignment of a name and an object. Okay, and we can also, if we have any kind of collection of objects, we can make assignments directly by unpacking the contents. Like here, we can unpack the contents of our tuple with 3 elements into 3 different variable names. All right, so you've got a lot of options available to you. Okay. Now, putting some of this together, and this isn't syntax you need to use, but there are usually a lot of constructors for something. Okay, and it's usually the case that if you want to make a list, you can say a list B and just put some stuff in between square braces. Okay. And you can print that out. Another thing you can do is make a list of something just by using the word list, like so. That'll create an empty list. All right. If you wanted to make a tuple, you can put it in some stuff in the round braces. And ask it to report itself. And a tuple is going to report itself in between curly braces. You can also just use the word tuple as a constructor, and it'll make an empty version. All right. So just be aware that there's different ways to make the same kind of an object. One thing they wanted me to show you guys is a particularly weird constructor. And you can make, if you just say 1, 2, 3, that is, I'll put a note here. This is an alternative constructor for a tuple. And you'll see that when we execute it, it represents itself between these parentheses. If we're not sure, we can ask it for the type, and then inside these parentheses, we can say 1, 2, 3. Let's see. I guess that didn't work. Let's call this variable t 1, 2, 3, and then we can ask it for the type of t. That will work, and it'll tell us it's a tuple. And if we just ask it to report on itself, it'll show us it's a tuple. So it'll tell us and show us. Now I'm just going to put pretty weird. You can do something like this. You can say ABC equals T, right? And that is going to unpack the values of T, the tuple T, into A, B, and C. So we can print out A, B, and C like this. Okay. We can also say A, B, C is equal to 1, 2, 3. And the result is the same. Okay, so this is actually the weird one. Okay, so sometimes you'll see this particular constructor. It's very parsimonious, which is a fancy English word for meaning easy and small. And it does a lot of work with one line of code. So we've created 3 names in our namespace. We've created 3 values. We've created a tuple object, and we've done an unpacking operation. Anyway, they just asked me to show you this. And it's probably good to know in case you ever see something like it go by, but don't feel a need to wrap your head too far around it. Just put it in your memory somewhere as something you might run into sometime, and you'll kind of maybe remember what it is. Okay, so this has all been in the topic of assignments. Right, you can assign things with equal signs. directly. You can assign variables to variables. You can assign multiple names to the same object. You can make assignments of names and values by unpacking any kind of collection. And a collection might be a tuple or a list or a string, or it could be any collection in the Python world. There's lots more that you'll run into eventually. Okay, and you can basically do constructors and assign things, combining a constructor for a variable type. Okay.
Pat, I have a question. Can I ask a question?
Yeah, absolutely.
Is there a difference between tuple and list?
That is a very good question. Yeah, there is. And let's, oh, what have I done here? I want to make this a markdown cell. And I'm going to say tuple versus list. Okay. And the answer is a tuple is an immutable list. Okay. So we can't change it. So if we have a list, we can make it with square braces, like so. And we can make a tuple C, and we can use the word tuple as a constructor and give it our list, like so. So let's print out our list C and what kind of variable list C is. Okay, we'll see it's a list. We'll see that it presents itself as being between these square braces. And we can do the same thing with the tuple we just made. So, and we'll see that it presents itself as a tuple. It's got the rounded braces. It's got the same information. Okay, now I'm going to show you this. If you're playing with Jupyter, you can hit a Control S and you can split these cells. And I'm going to show you the difference in the directory between the list and the tuple. And the directory command, you'll recall, is going to give you all of the things the object knows how to do. Exactly what they do isn't so important here, but I wanted to show you the difference. You'll see that the list and the tuple have a lot of the same things they know how to do, right? They know how to add, and they have a class and all this gobbledygook, hard to interpret stuff. But if you look down here after all the stuff with the underlines, you'll see that there's only really a couple things without that don't start with underlines. And that generally means these are the things that you're supposed to use, right? You're supposed to use count and index in a tuple. But in a list, you can use append, clear, copy, all this other stuff. And the point I want to make here is there's a much longer set of things in the namespace of a list than there are in a tuple. Okay, so a tuple is a very lightweight version of a list. You can see it's got the same information. But because you can't change a tuple, because it's immutable, the tuple doesn't need to know how to insert something into itself or reverse itself or copy itself or append to itself. It doesn't need any of the methods that an object that can change will need. Right? So it takes up less space. Okay, it's more reliable. You can change a list, but once you make a tuple, you can never change it. It's like a string in that way. So if you need an object that's unchangeable, like you're going to use it as a key in a dictionary to look things up, you probably want to go for something you can't change. If you're going to make a list of the people in your family or the planets in the solar system, you might as well use a tuple. I mean, people are going to argue whether Pluto is a planet, you know, probably for 1,000 years, and Pluto might come or go, but you know, the planets around the sun are pretty much immutable. You know, you might have a kid and then have another kid, but for at least around a year, the size of your family isn't going to change. So, bottom line, tuples are immutable. Tuples are thrifty. They take up less space, less resources, but you can change lists. Good question. Any others? Okay.
Thank you so much, Pat.
Sure. Not a problem. Yeah, let's just do a few more variable assignments. Because one of the cool things about Python is you saw that if we had tuple C, it came back and it looks like a tuple, right? And if we have a string, and we ask it for the string, it comes back looking like a string. I mean, that's really super polite. Python will do that with number variables too. So if we wanted to say int1, make it equal to 1, like so, we can do that. And if we wanted to say float1 equals 1.0, we can do that. And then if we ask it to, we ask these things to represent themselves, they will look different. So if we say int1, it's going to look like an integer. It won't have a decimal point. And if we say float1, it's going to look like a floating point, right? It's going to have a decimal point in it. And even if we didn't put the 0 here, we could just say 1 point. It's still going to be smart enough to know that it's a floating point, and it'll put that 0 in for us. So these things will represent themselves very nicely. I should put in another heading here. And we can say is what you see is what you get. Sort of. Okay. I'm just going to make this a little smaller. Okay, so Python is really good about showing you what it thinks something is. And it's usually the way you go about making one. Right. Let's see. Next topic they wanted me to cover here is PEP8. We looked at that a little bit last time. And I'll just show you a few slides here so we don't belabor too much. Now, as you can imagine, it's really easy to write hard to read code, right? There's a lot of it in the world. And PEP8 is the coding standards that Guido van Roosten came up with as one of the first things ever that he did with Python. All right. So some basic rules is if you have just regular ordinary variables like we've been working with, put them all in lowercase. Okay. If you have multiple words, use an underscore to separate the words. Okay. It's this has nothing to do with Python syntax, right? You can use the interpreter for the most terrible variable names ever, and it won't complain. But the humans that'll be reading it will have issues with it. And really, computers are so cheap and so fast, you're usually not trying to economize the amount of work a computer does, right? That's the lowest cost element of your system. The highest cost element is human time, particularly your time and your colleagues. Okay, so this is a really good way to write regular variables. Some things you want to avoid is you want your variable names to be sensible, right? You don't want people to guess what the hell they mean. This is a terrible variable name. And it'll depend on the font you're using in your editor, but that looks just like a 1, doesn't it? Slightly different. So you don't want to use a lowercase I or an L or O's. You don't want to have you generally don't want to have a single character variable name unless you're just using it as an index or something, because it doesn't tell you anything about what it's representing, so it adds no information, and in this case it just adds confusion. Okay, don't use an O either, I mean, just because it can be confusing. And certainly don't use a single O as a variable name. Now, if you try to use the wrong kind of variable, or a variable that just doesn't work syntactically, like if you wanted to say a number like 3 and you want to make an assignment to something like this, Python won't let you do it because 3 isn't a good variable name. Okay. And if you wanted to do something really stupid, like say false equals true, it won't let you do that either. So there's some things that Python won't let you do that are so stupid the interpreter will even yell at you. But there's plenty of things you can do that are just like terrible to your user, like naming a variable after your dog, which I'm just doing for fun. But you generally don't want to do that. I had a computer science teacher in college, and I don't know whether this is true, but he said he knew somebody that got fired because one of his variable names was LVB RIP, and it equaled something like 1834, something really like that. Anyway, this guy was really into music, and he meant this to be Ludwig von Beethoven. RIP is rest in peace. So he meant to assign a variable to the year Ludwig von Beethoven died. And it's like, I don't know whether 1834 is right, but like, who the hell can know that? So anyway, the PEP 8 takeaway is make variable names that are readable, they're intelligent, and they don't have ambiguous characters in them. Okay. Another thing you don't want to do is you don't want to name a variable after something that Python already knows about. All right. I'm going to digress just a little bit here. I want to show you a couple of things that are a little off script, but you kind of need to know. So under the hood, and we'll get more into this in a later lesson, I think. But you can have a dict object that's a dictionary. and you can make it with squiggly braces, and you can say, you can assign a key like A, and you can make it equal to some value like 1, 2, 3. And you can make another key like B, and you can associate that with some other value. All right. And you can get an object out of it by providing it the name of one of your keys. We need an assignment operator here, don't we? Okay. So here we've made a bunch of associations between names and objects. Right. So we got a couple of names, they're keys, and we can get the objects 1, 2, 3, and 2, 3, 4 out of it. Now, if we're just asking for a key, like we don't need to know what's in the dictionary. All we need to know is there's a key called A. And if we ask for it, it'll return the associated object. Well, the reason I'm showing this to you now a little bit ahead of time is this is how Python keeps track of the names and objects that you assign to the namespace. So if you assign a name dog to something like Quinn, like so, and then you ask for dog, what you're really doing is dog is now the key to a dictionary, just like this. And if you make an assignment operator, you're assigning the name of something to its value. So this dictionary object and this assignment are really kind of manifestations of the two concepts of taking a name and associating it with an object of some kind. And Python, invisibly to you, unless you ask, works with a dictionary where it keeps track of all its names. In fact, this pairing between dog and Quinn happens in a Python dictionary that Python reads. Okay, so why is this important in names? Well, it's important because Python knows about a bunch of stuff. Okay, so Python knows what print is. It's a function. All right. It knows what none is. It's a null object. Okay. We've seen the word for. So we can say for element in a list, and we can ask it to print an element. Okay, so for and in, and they show up in bold print here, are words already known to Python. Okay, in this case, they're keywords. Print is a function known to Python. Okay, it already knows it's a function. So these things are already in Python's internal dictionary. Okay, so what you don't want to do is you don't want to assign something different to the same word. And I'll show you what I mean with our little dictionary here. If we said that our dict object A is now equal to some stupid number, now we can say dict object A, and it'll give us that stupid number. Now, it won't give us 1, 2, 3 anymore because it's got overwritten. Okay. In Python, you can do the same thing, and you can do it accidentally. And I'll show you this. You don't necessarily want to try this at home, but again, you can't break Python. You could say Let me get rid of a couple cells here. Okay, so we said print, and Python came back and said it's a function I know about. And if we wanted to print 1, 2, 3, or 1, 2, 4, it'll go ahead and do that. Now Python is kind of forgiving, right? You can now say print equals hey Quinn. Okay, and now you can ask it for print, and guess what? You've changed the Python language accidentally, right? So this is no longer the function print. We can't use it anymore because we've assigned the object associated with the word print to this string. We've broken Python. It's easy to fix. We'll just restart our kernel like so. And we'll get a fresh version of Python. And we're going to okay, so we're going to execute this cell again. Actually, we're going to get rid of this one so we don't have to do that again. We'll just comment this out like so. So now if we ask it for print, it knows about the function print again. All right. Now, if you do something like this, like I say, you haven't broken Python, and all you got to do is get another interpreter going. So you just, if you're in a shell, just close the shell and open a new one. Or if you're in a notebook, just reset the kernel. But you get some really weird errors if you do something like this. And maybe you won't be able to debug them easily because you'll have forgotten what you did. And it might be that your code gets ingested by somebody else's code and you've done something like this, and you're going to drive your partner insane because they'll have to read all your code to figure out what went wrong. So there's things you don't want to use. And let's make a list of them. And we'll make this markdown and stuff you don't want to use. Names not to use. Okay, and that is going to include keywords. So what are Python's keywords? One way to find out is you can say import keyword. And that just brings a little bit of something extra into the namespace. And the namespace is just Python's internal dictionary. So you just added something to your internal dictionary here called keyword. And you can say keyword.keywords. I think it's KW list. I forget. Yeah, there it is. So this tells you all of Python's keywords. And if you want to know whether something is in your keyword list, you can say trial name. You can use the keyword in, and this will tell you whether or not the name you intend to use is a Python keyword. And no, it's not. That's one way to check. So don't use keywords. And this is how to check, or one way to check. All right. Another thing you don't want to use is any word that Python knows about. Okay. And one way to check is just type it. So type print. Or like if you're thinking of doing trial name, And it gives you a name error. Okay. You're good to go. It doesn't know what the heck it is. Okay. If Python doesn't know what it is, you're okay. Another way to check, and we'll just get rid of this output here because it's ugly. Another way to check is try to import it. Because if Python thinks it's a library it has access to, it'll know about it because we could just go ahead and import keyword. Okay, and I know we're just about coming up to break, so just bear with me for another moment. Okay, and this should give you or maybe it's an import error. Yeah, module not found error. Okay. All right, and let's see. Yeah, okay. So don't use keywords and don't use words that Python already knows about, and you should be in pretty good shape. Usually you can find that out just by typing it. And if Python doesn't like it, it'll find a way to yell at you. If it's specifically a keyword, you can specifically ask about it. Okay. And I guess we should just, for completeness here, say no really short words or L, O, and O. Okay, so it's time for break. Let's come back again at the top of the hour. And when we come back, I'll show you a few ways to do type conversions and give you a real quick tour of some of the more common variable types and how to get extra ones if you're not happy with them. So I'll see you in a few minutes. Thanks. Hey guys, welcome back for our third and final torture session for the day. Do you have any questions from what we've talked about so far? Okay. Well, we've covered quite a bit. We've talked about several different ways to assign variable names. Most of them involve the equal sign operator one way or the other. We can unpack objects like strings that actually contain a lot of little objects inside of them. We can do a direct assignation of a value. We can assign the value of a variable to the name of another variable, easy enough. We do assignments all the time, really. I mean, anytime we create a variable like this, we're making some kind of an assignment. Usually we're using the fact that Python is pretty compact in that we can use an assignment operator, assign a name and a value in one fell swoop, and Python will go ahead and infer the variable type for us. We've seen in a lot of examples like the strings and the integers and the floats and the lists and the tuples, where Python will come back and it'll, when you ask it to report out a variable, usually you don't even have to ask it the type. It'll show you the type, right? It'll put quotes around it or square braces or parentheses, or it'll put a decimal point in there. So it'll tend to tell you what kind of variables that it's produced. Okay, we've learned about some tips for naming things. Pepe, as you saw the other day, is a lot more complicated than that. I still recommend giving it a read if you get time. It's just got a lot of really good styling tips in there. We mostly talked about what to name objects and what not to name objects. We don't want to name objects after something Python already knows about, like it knows what print means. We don't want to goof it up. We can if we want to, but we can get in a little bit of trouble, mostly from a debugging perspective, but we're not going to be able to break it. If you're wondering what variable name to use, one way to check if you shouldn't use it for sure is ask if it's a keyword. You can ask directly or just type it in. Okay, if you type it in, like you just type the word "and" in. That's not a very good example. If you just type the word "for" in, it'll tell you something about it if it recognizes it. This says invalid syntax. Let's put lambda, which is another LAMBDA. Lambda is a keyword, and it'll tell you something about it. Here we have a syntax error. If you put in something like an int, it knows what that is. So generally, if Python knows about it or gives you a syntax error, that means, you know, it thinks it knows what to do about it. If you get something like a name error or a module not found error here, you're really sure that Python hasn't a clue what that name means. That means it's fair game. You can go ahead and use it. So you've got a lot of ways to check yourself and see whether you're onto a name that makes sense. One other thing I should mention is a lot of people are into something called clean code, and that means they like to write code without any comments at all. So it's really important in a clean coding environment is to make variable names meaningful. So make it so you don't need comments. Okay, optimally. I won't discourage you from using comments. I think they're a whopping good idea. And I've been involved with projects that are really into clean code and found them hard to understand. But just know there's clean coders out there. And it's actually becoming a norm. You can't have comments. So that's where your variable names are very important. Okay. So got a couple other topics here. One is let's talk a little bit more about the print statement. And print is a function, and it's lowercase. Okay, and the basic use is you can say print, and you can give it in parens a list of things to print, and it'll go ahead and print them nicely. And if you just say print and you don't give it any arguments at all, it'll print a blank line. Like so. Okay, and that's its basic use. If you want to get a little more advanced, what you can do is you can ask for help on the print statement. And I'm going to hit Control B to get a little pop-up window here, just so we can grab it. And if you look at it, this will give you its signature. Okay. And we'll just copy it down here so we can look at it, and then we'll get rid of this box. So
I have a question. Can I ask something?
Yeah.
In this part, can we use the all function, for example, I don't know what is the function. Can I use this pop-up window?
If you want to, if you got, yeah, absolutely. Because if you hit Control B, it pops up. And yeah, you can type in a line at a time and it doesn't mess up your notebook.
Okay, thank you so much.
Yeah. And hit Control B when you want to get rid of it. It just toggles. Okay. So, the signature tells you roughly how to use it. To interpret it, this bit of it just says you can give it one or more values if you want to of stuff to print. And then kind of like with our dog and cat function, remember our signature looked something like, we had the keyword def and we called it function. And then we said dog equals cat equals. That's what the first line of the function looked like. This is called a header, by the way. So the help will give you what the header looks like and how you can use it. And if you remember here, it meant dog and cat are optional, and we have default. Is equal to the none object. Well, the print function kind of works the same way. We can give it any number of values, and then it's got they call it a keyword argument, where it says something equals, sep equals, or dog equals, or cat equals. And what this sep is, sep is what separates the stuff printed. Okay, and the n is what gets printed at the end. Okay, and the file equals, just for completeness here, this file equals sys.std out. That just means it prints to the terminal. You can also use it to print to a file. Okay, but the sep and end are the interesting things. So if we wanted to use a sep equals argument, we could do that. We could say print hey and you, like this, and whatever else we wanted. And we could override the default separator, because right now the separator is a single blank string. Well, we could put any kind of string in here at all. So we could put a blank and then a few of these guys, like so. And for the end, we can put something like the end, and then the /n for a new line character. So what that's going to do is it's going to stick in our custom separator, and it's going to stick in our custom end. Probably look better if we had another space here, but you can play around with it. All right, so you can mess around with it. So you might, I mean, this is kind of a dumb example here, but if you wanted to have a comma separated list, you might say you want to do a comma and a space. And for the end, you might just want to leave it as /end, or just get rid of it altogether, because we'll apply the default. So that's how to make a comma separated list.
Can I ask a question?
Yeah.
I cannot print value. Print. I write print one, but I have a type error. Yes, a reason.
Well, let's see.
Cannot.
So if you just say print and then
Hmm.
open and close parens, just put in a couple of numbers. I don't know, 1, 2, 3, just a couple random numbers and see if that works. Because it could be that you're trying to type in something, you don't have the right quotes around it or something.
I still have error, but I don't know. I figure it out.
Oh, okay. Why don't you paste what you're trying to do into the chat, and I'll have a look at it. So there's a channel called Class Chat, and if you get it, I'll paste it in.
Okay.
Okay. So that you can play around with the print function. It actually be good practice for you to do so. You can use help, right? To get more information to get the signature. And then you can play around with some of the elements. Okay. Okay, so let's talk about a couple more variable types. Okay, hang on. Ekron, I just got your Slack. Let's see, and it looks like you're trying to say print, and you're saying 2134. And that's going to work for me. And it didn't work for you because it's saying a string object isn't callable. And I think you probably hosed up print like I did. You might have said print equals, and you gave it some string. And if you do that, it's going to redefine print. So if you ever get weird stuff like that, just come up to here and say kernel and restart the kernel, and that'll clear your session and it'll give you a fresh Python. And I'm sure that'll work for you. Okay, so let's go for a few more variable types. Let's make a markdown cell to delineate it. If you still have problems, paste in what you're trying to do, and I'll look at it when the class is done, okay? Okay, so Python supports natively it'll support a string object, and it'll support a float, complex, okay, and an integer. Okay, those are the main types that it'll do right out of the box. It'll also do a Boolean. All right. So we've talked about a string. Okay. And we've kind of talked a lot about that, so I don't think we need to do that right now. Okay, you've got integers, and an integer can have a sign or not. So you can say 1 is going to equal +1, or -1 can equal a -1. Okay, so it'll ignore the plus, but you can put it there. It's completely happy, and it'll take a negative sign. So these are technically called signed ints, signed integers. And that's because the register, you know, the bit of memory that holds it has room to hold a minus sign or not. So if you're familiar with C, there's also sometimes even in Python there is an unsigned. Okay, and an unsigned int doesn't have an extra bit at the beginning of it to hold the minus sign. So it's a little bit more efficient if you know that everything is going to be a positive number. Okay, floating point numbers are called float. Okay, so if you have a number like 123 dot whatever, that's going to be a floating point number. So you can say float is going to be equal to an arbitrary number with a decimal point, and negative float can be any random negative number. Okay, and they'll introduce themselves with a sign or not and a decimal point. Now, one thing you got to know about floats is floats are inaccurate. Now, what do I mean by that? I mean, 234.234 looks pretty accurate, doesn't it? But under the hood, behind the scenes, a computer has the option of having a 0 or a 1, okay? And it has a bunch of these, and it puts these together to make numbers, okay? So something like 001 under the hood equals a 1, okay? And 0, 1, 0 equals a 2, and 0, 1, 1 equals a 3, and so on. Okay, and that fits really nicely. These are integers, and they're accurate. But if you do a floating point number like this, somehow you got to squeeze this number into the stuff inside of a computer. And the stuff inside of a computer can only understand zeros and ones. It's not its fault. Computers are basically just stupid. But it doesn't store floating point numbers very well. It'll get them kind of close, but not terribly accurately. And if you don't believe me, you try this. Type in 0.1 plus 0.1 plus 0.1. And look what you get. You get 0.3, right? But you get more. You get all this junk, and by the time you get to the end of it, you got a 4 in there. What's going on with that? Well, that's just kind of, it's a leftover from the fact that computers can only store zeros and ones. It'll do its best job, but your floating point numbers are not reliably accurate. Some are more accurate than others, for sure. So, you know, if you wanted to do a floating point division like 1/3, another reason they're inaccurate is it just runs out of room, right? Because the memory allocated to hold this object is finite, right? It can't go forever, right? So you get a number like this, it's going to be inaccurate because you just run out of register space. All right, and there's a whole bunch of numbers like that. Like what? It's another one. Yeah, 1/6 just goes on forever. Okay, now at some point you can round these things. So you can say round 1/6, and it'll do a reasonable job of that. And you can play around with how round it is. You can tell it how many decimal places, but it's always going to round it off. Right? It's never going to be right. So if you ever need, this is kind of beyond the scope, I'll just throw this out. If you ever really need accurate numbers, you can use other libraries. Okay, and one you can get to by, you can say from decimal, import decimal. I think that's it. Yeah. And you can say from fraction, import fraction. So from fraction, import, maybe it's that. No, maybe it's this. No, shit, just a second. So we're just going to ask it import fraction. Oh, fractions. Sorry, I'm flailing a bit because I'm ad-libbing. Yeah, here we go. So from fractions, import fraction. There we go. Okay. So if you want to represent 1/6, you can do something like fraction and give it 1/6. Okay, and it's going to store the numerator and denominator separately. So if you wanted to add up a bunch of 1/6s, you could use fraction, and then you could divide the numerator and denominator when you're done and get a regular floating point number out of it. So anyway, you can call help on these if you need them. All right. Anyway, if you're doing a banking application, you know, where you're calculating interest rates and stuff like that, you know, with really small numbers, you want to use one of these. And what Decimal will do is it'll provide a temporary context or sandbox. And you can get, you know, like, you know, 5,000 points of precision. Okay, and fraction keeps the numerator and denominator real numbers. Okay. But these aren't part of Python's main library. Another thing there is complex numbers, and we'll do a markdown cell here. Okay, now complex numbers. Well, you know, most people, if they need complex numbers, they know all about them, and if they don't need them, they don't need them. Complex numbers have a real part and an imaginary part. Imaginary. Okay, and that's like it equals a number plus or minus something, another number, times square root of -1. It's just really weird. Anyway, what complex numbers give you basically orthogonal planes. So you get axes that are like this. So it doubles the amount of information you can have in an object, and it works out really well for a bunch of stuff. So you can make a complex number by saying C equals complex, and you can give it the real part and the imaginary, like so. And if we ask it about itself, you'll see that it represents itself in parens, and there's always going to be something plus or something minus something else. You can also say a regular constructor might be something like 3 minus 8j, and that will also resolve into a complex number. The one thing I would point out here is that in some disciplines, in most math, the square root of -1 is usually I. In Python, it's J. That's the only difference. Anyway, it's got you know, all the stuff you can possibly do. So you can like add complex numbers, and it'll separately add up the imaginary and the real components. So it's there if you want it or need it. There's any questions on these number types so far? Okay, there is also a Boolean number type. Okay, and a Boolean that's just a fancy way to say it's true or false. Okay, the variable type is Boolean. So if you want to say that our trial is true, okay, we've got some positive result, we can print the type of our trial, and we can type the trial itself. We'll find it's a Boolean data type. Okay. True and false are both Python keywords. And we can say true in keyword .kw list. Wait, hang on. Could it be that I've just lied to you? I don't think so. I'm pretty sure that true and false are keywords. Yeah, sure enough, they are. And I don't know why this. Well, false is sure in there, and true. Yeah, true and false are both in the keyword list. So this command failed for whatever reason, but I don't want to belabor that. So true and false are both keywords. You can do something like true and true. So you can do comparisons with them. You can say true or false, like so. And I think you can even add them, because true has, yeah, let me just make a note here. So true has a numeric value equivalent of 1. false has numeric value equivalent of 0. So you can use these things to do math, basically, if you need to. So true plus true equals 2. And this is one of the few cases where if you combine two values, you add two values up, you get a different type of value, right? So you can ask it for the type of true plus true, and you'll find you have an integer as expected, even though true itself is a Boolean value. Okay, does that make sense? Right. And one other thing I would point out, and I'll just put these under the category of exotics. Down the road, you're undoubtedly going to get into things like data science and analytics. Okay, and in Python, these are, you'll use objects from NumPy, and you have to install NumPy. You may have to install NumPy using Conda. So if you said Conda install NumPy, you would get it. I've got it on my machine. You may have it on yours. But if you imported NumPy, like so, NumPy has NumPy is built on C, and it's compiled. It has compiled data types. All right, so it's going to have, they're called C types. Okay, and those, whatever you have on NumPy on your machine, these will be the C types supported by your hardware. Okay, and by your C compiler. Okay, and might be limited by your CPU and your bus architecture. Okay, so that'll have things like float 32 and float and complex 64, and the number tells you how wide the number is. And here you might get an integer 8 or a uint 16. So it's going to have data types that will remind you of the ones in baseline Python, but they'll be the kind of data types the C compiler understands, and they'll be used everywhere in NumPy and everything that depends on NumPy. So it'd be other stuff like pandas and PyTorch and stuff like that. TensorFlow, all that kind of stuff you use for machine learning relies on NumPy, which relies on C, which relies on a whole bunch of stuff that has to do with the particular hardware you're on. Okay, so these are not really like part of Python, but NumPy is part of the Python ecosystem, so you should just know this. But even if you're working in NumPy and you're using tensors and all this weird stuff that you find in machine learning, you can still rely on the Python data types, because the Python itself is the base of all this other fancy software you'll get to eventually. Okay. Get rid of this. What else do we want to show you here? Okay, type conversion. We talked a little bit about type conversion. But I'll talk about it just a little more here because it's pretty darn useful. Okay, so we have looked at the types int, float, string, complex, and Boolean as our main data types. And Boolean is just spelled B-O-O-L. Okay, we've looked at all these. And if you ask it for the type of something like 1.23, it'll come back and tell you it's a float. Okay, now all these data types can be used as verbs. Okay, and they can do typecasting. Okay, and typecasting is changing the kind of variable. All right, so it could well be that you're working with a number or an object like a string. We'll just call it S for short, and it's 1, 2, 3. And this might come up if you have something like input, okay, and you might say, give me a number, like so, and you might say your number equals the result of your input. Okay, the input command solicits input from the user. And if you give it a number, like 1, 2, 3, dot something like that, and then ask it for the number, you'll see that no matter what you type into one of these input dialogues, you're going to get a string out of it, because that's all it knows how to do. But if you want to use this as a number, you're going to have to do something about it. So if you want to change its type, then you can use one of these other data types to convert it. So you can say int number, and that'll automatically, oh, okay, it didn't like it. We could call it float. They don't always work on all those things. If we ask this thing to print our number and our float version of the number and a type of the float version of the number, float num type float num, we need one more paren here. Okay, so our original thing is a string, right? We can make a floating point number out of it, and in fact we can see that it turned into a floating point. So you might want to convert something that had to come to you as a string. Maybe you read it from a file, you scraped it off the web, and you want to convert it to a number. You can do that. Okay, you saw that not everything works. Let's make a new number, and let's call it 1, 2, 3, 4. Okay, and that's an int. Okay, we can ask this to be a float, like so. We can ask it to be a complex, and it will. We can ask this to be a string, and it'll become a string. And you can see how Python's presenting these numbers to you, what type they are. You don't really have to guess, do you? All right, so just use them as a verb and you'll be fine. All right. Now, some of these verbs have different constructors. And you can find out. How do you find out? Well, you just ask it, say help complex. Right. And this shows you, like, remember our function with dogs and cats? Well, we had placeholder values. Well, complex has placeholder values too, doesn't it? It has 0. So if we wanted to, let's just put this in here as a comment. So we can say complex, and we can give it a real part and an imaginary part, or we could just say num, and it'll convert for us. We can say complex, num, and we can give it an imaginary component, and it'll take that in. So any permutation of complex and 1 or 2 arguments is going to result in a complex number. If we ask it for the string help, it shows us there's a couple of different signatures. Okay, we can say string and we can provide an object to it. It'll convert it to a string. If we don't give it anything, it'll give us a null object. So if we just say string like this, it'll give us an empty string as advertised. We can tell it encoding, what kind of formatting, like UTF or whatever, to use in its conversion. So anyway, all of these objects as verbs are going to have the signature and help, right? So if you want to play with it, I'd encourage you to. And they'll all be a little bit different, but they compare way more than they contrast. Okay, so we're about done for tonight. To summarize, we've talked a lot about the different kinds of objects available in Python. We talked about strings quite a bit. We've got floats, ints, and complex numbers as number types that are built into the main bit of Python. We found that you can often use the names of the objects as verbs to convert between one kind and another. You've seen a little bit about how to make simple functions. You've looked at, besides some of these objects as verbs, you've looked at how to go to help and then how to parse out the constructor for the object you're interested in and make good use of it. Like for print, we were able to figure out how to introduce a separator and an end of line characters, so we can customize it a little bit. You've learned about some exotic or interesting and cool data types that aren't exactly in the Python library, but you could find them useful. Things like fraction that lets you keep the 2 parts of a division separate. Decimal that lets you make contexts that let you have infinite precision, which gets you around some of the issues around float, which has problems with the size of the register it can possibly hold, and mechanical problems around holding numbers that don't fit neatly into a base 2 system. All right. You've learned a little bit about PEP8, how to make sensible variable names, how to break Python and how to fix it by overwriting elements in its namespace. So you've actually learned a lot today. Now, you don't have to remember everything that we talked about. You know, if you emerge from this session knowing that there's a bunch of data types and knowing roughly what to do with them and knowing how to find help, you'll be in great shape. But you should be able to look through this in your spare time and be able to pull and unpack and steal a whole bunch of information that ought to help you out as you're trying to learn this stuff. My main message here is don't feel a need to master every little bit of piece of minutia that we went through. You know, get the big picture stuff and know you can always look up the other stuff. Okay. Does anybody have any questions? No questions. All right. We'll save
No
them up for next
questions.
time.
But thank you so much. There are so many information today.
Yeah, I know. It kind of
Yeah.
gives you a headache, doesn't
Yeah.
it?
Thank
But
you.
anyway, I'm serious. Don't kill yourself trying to think you need to get this all into your head right away. So I will post this in the class chat message, so you can download it and play with it. If you have questions between now and the time we get together, do post them. I'll try to have a look, and if I can't have a look before the next class, I'll have answers for you by the time we actually meet. All right. So thank you, and have a great rest of the night.
Good night.
Thank you. Good night.
Thank you. Good night.